Welcome pre-cal students to the homework help video, page 617, numbers 1 through 13. Let's go ahead and get started. And let's take a look at number 1. We're going to solve the right triangle. And let's go ahead and draw our triangle here. It does not have to be drawn to scale, please remember that. And let's go ahead and get started. We'll call this angle A, this C, and this B. So side B is 10. Angle A is 20, and of course we know this is 90. Alright, here we go. We know two angles, so very quickly 20 plus 90 is 110. So angle B has to be 70 to give us a total of 180. So the measure of angle B equals 70 degrees. Now, you can solve for side A next, or side C. I'm going to solve for side A. I'm going to solve for side A first. There's no certain reason I'm doing that. I just feel like side A is the best, so I'm going to solve for side A. And then, of course, I'm going to have to pick an angle, either 70 degrees or 20. I'm going to go ahead and go with 70 degrees. Okay? So, if I'm going to use 70 degrees, this side over here would be my opposite side. This would be my adjacent side. And of course, I don't want to use C because then I would have two unknowns. So I'm going to use these two sides here, adjacent and opposite. So with that in mind, here we go. We're going to say that we have the tangent. The tangent of 70 equals opposite over adjacent. And then, of course, I'm going to multiply both sides by A. So if I multiply the left side by A tangent of 70. If I multiply the right side by A, I'm left with 10. And now to get A by itself, I'm going to divide both sides by tangent of 70. So A equals 10 over the tangent of 70. So real quick with my calculator, I have 10 divided by the tangent of 70. And that would give me 3.639, so 3.64. So the length right here of A is going to be 3.64. And now, students, in order to find the last missing side, I'm just going to use Pythagorean's theorem. I have one leg, which is 10 squared. I have another leg, which is 3.64 squared, equals my hypotenuse C squared. So I have 100, 10 times 10 is 100, plus 3.64 squared, and that's going to give me this right here, 113.2496 equals C squared. Alright, so take the square root of both sides, and the square root of 113.2496 is going to be 10.6418, so 10.64 is the length of C, 10.64. And there we've solved the triangle. Okay, let's try number 3. All right, let's go ahead and draw our right triangle here. And so here's our right triangle. We'll call this A, we'll call this C, we'll call this B. Angle B is 71 degrees, angle C is 90, and side B is 24. Now, very quickly, we can find the measure of angle A. 90 plus 70 is 161, and so we would need 19 degrees to give us 180. Okay, let's go ahead and put 19 degrees here. There we go. And let's continue on. Now, you can solve for side A if you want to, or side C. I'm going to solve for side A, and I'm going to use this angle here. So if I go across, this would be, I think this time, students, I'm going to try something different. No reason, just to show you that you can use other angles. I'm going to use angle 19. Okay, so going across from angle A, this is my opposite side. This side right here would be my adjacent side. Obviously, I'm not going to use side C because I would have two unknowns. And so here we go. The two sides I'm dealing with are opposite and adjacent. So if that's the case, then I want to use tangent. So the tangent of 19 degrees equals opposite over adjacent. Multiply both sides by 24, and I would have 24 tangent of 19 degrees equals A. So with my calculator very quickly here, 24 tangent of 19 degrees would give me 8.263. And the directions did say to round to 2 decimal places, so I'm going to put 8.26 for A. So here's side A, 8.26. 8.26. Now students, I do know a leg. I know another leg, so let's use that with Pythagorean's theorem. So I have 24 squared plus, and remember, you can only use Pythagorean's theorem when you have a right triangle. Okay, please don't forget that, students. Okay, so here we go. I'm going to type into my calculator 24 squared plus 8.26 squared, enter, and I'm getting this right here, 644.2276 equals c squared. Hopefully I'm not making a mistake anywhere. Take the square root of both sides, and you get 25.381, so 25.38 equals c. So there's c. And students, we have completely solved the right triangle. Okay, let's try number 5 real quick here. Okay, let's go ahead and draw our triangle first of all. We'll call this A, we'll call this B, we'll call this C. Side A is 6. Notice I go straight across from angle A. Side B is 10. Notice I went straight across from angle B, so side B is 10. And now, whenever you know this is 90 degrees, whenever you know two sides of a right triangle, very quickly, you can use Pythagorean's theorem to find that third side. So we're going to have 10 squared plus 6 squared equals c squared. That's going to be 136 equals c squared. And the square root of 136 would be 11.6619. So we're going to round to 2 decimal places. 11.66 equals c. Now students, remember what I've taught you. Next we're going to find one of the missing angles. Find or solve for the smallest angle first. Okay, don't forget to do that. It's very important. Now later on I'm going to teach you why. We're going to get into law of sines, in which we have the one case scenario, or the one triangle scenario, the two triangle scenario, and the ambiguous scenario. And when that happens, you're going to learn then why it's very important that we solve for the small angle first. Okay, but anyways, moving on, here's side 6, and notice side 6 is smaller than side 10. Okay, so since side 6 is smaller than side 10, then we know that angle A, which is across from side 6, is smaller than angle B, which is across from side 10. So we're going to solve for A first because A is the smaller angle. Now next, students, think about it. You're welcome to use this side right here to solve for angle A, but why would you want to do that? That's a decimal number. I'm going to use this side here and this side here, okay? And this side here is called my opposite side, and this side here is called my adjacent side. So students, with this in mind, I'm dealing with angle A, opposite and adjacent. Well, which trig function uses opposite and adjacent? Tangent does. So the tangent of angle A equals opposite over adjacent. Now with your calculator, hit second tangent, and when you do, this will pop up, and then type in 6 divided by 10. So here we go. Second tangent, 6 divided by 10. And the reason you use second tangent, don't forget students, is because you're looking for an angle, okay? And you'll get 30.963, so 30.96. So far we found C. C was 11.66. Now we found the measure of angle A, which is 30.96 degrees. And now, students, very quickly we can find the measure of angle B. We're going to add angle C and angle A together and then subtract from 180. So what plus 90 equals minus 180. And students, after I've done that, when I've added my two angles together and subtracted from 180, I'm getting 59.036. So that would be 59, excuse me, that would be 59.04 degrees. Okay? All right, moving on to number 7. Always helpful to draw that right triangle real quick there, like that. Then let's go ahead and label everything. We're going to keep this A, keep this B, and keep this C to be consistent. Side B is going to be 16, side C will be 52. And so very quickly, let's solve for A using Pythagorean's theorem. Okay, so 16 squared plus A squared equals 52 squared. All right, 16 squared would be 256, and 52 squared would be 2,704. So we have 256 plus A squared equals 2,704. Now let's bring the 256 over and make it negative, and you're left with 2,448. And now we'll take the square root of both sides, and we'll get 49.477. So we're going to round that to 49.48. Okay, so there's A. We found A, 49.48. Okay, 49.48. Now, students, we're missing two angles. Okay, angle A and angle B. We want to solve for the smallest angle first. So we're going to draw a line going across from A and a line going across from B. Which side is smaller, 16 or 49? Well, 16 is. So if 16 is the smaller side, then B is the smaller angle. Okay, so we're going to solve for B. So I'm going to circle this angle here. Now, you're welcome to use 49.48 in order to solve for angle B if you want to. I'm not going to do that, okay? Because it's a big old decimal number. So I'm going to use this side over here, which is my opposite, and I'm going to use this side here, which is my hypotenuse, okay? So with that in mind, here we go. I'm going to go ahead and put the, we're dealing with opposite and hypotenuse, so which trig function will we use? Well, sine is opposite over hypotenuse, so the sine of angle B equals opposite over hypotenuse. Because we're looking for an angle, you would hit second sine on your calculator and this would pop up, and then type in 16 divided by 52, and you should get, let's see here, second sine, 16 divided by 52 would give you 17.920. So angle B, the measure of angle B, would equal 17.92. All right. And the last thing we're trying to solve for now would be the measure of angle A. And of course, we can do that very quickly by taking angle B, 17.92 plus 90, and subtracting it from 180. So here we go. We're going to add those two together and subtract from 180, and we're going to get 72.07. So 72.079. So 72.08. 72.08 degrees. Okay? All right, moving on to number 9. Okay, now we're dealing with minutes and seconds, which is really no big deal. I'm going to go ahead and encourage you to put this into a decimal form. So remember how to do that. It'd be 12 plus 15 over 60. So 12 plus 15 divided by 60 would be 12.25. So I would encourage you to use a decimal in this case, students. It's my advice. And let's go ahead and draw our right triangle here. This will be our A, this is our C, this is our B. Put 90 degrees here. For A, we're going to put 12.25, okay? Well, let's find the measure of angle B very quickly, please. We're going to go ahead and add 12.25 plus 90 and then subtract from 180. So let's do that quickly. Let's see here. We'll get 77.75. So angle B is 77.75. Okay, 77.75. Now we also know side C. I just forgot to write that. So side C would be 430.5. So what we're missing is A and B. Now students, it really doesn't matter which side we solve for. I'm just going to pick A, and I'm going to choose to use, I don't know, I guess this angle here looks good. Now I'm going to use this angle here to help me find side A. There's no way the other side that I'm going to use is going to be side B. That'd be two unknowns, A and B. So I'm going to use this side here. So based on angle B, and by the way, students, you could have used angle A if you wanted to, but based on angle B, my two sides here would be adjacent and hypotenuse. Alright, so here we go. I'm going to use cosine because adjacent and hypotenuse, that trig ratio is cosine, so cosine of 77.75 equals adjacent over hypotenuse. Multiply both sides by 430.5. Let's see what we get. 430.5 cosine 77.5 or 77.75, and you would get 91.342. So we're going to call it 91.34 equals A. Okay, we'll slide that right up here. And now students, very quickly we can solve for leg B or side B by using Pythagorean's theorem. So one of my legs is 91.34 squared. My other leg is B squared, and that would equal 77. That would equal 430.5 squared. Now students, I'm going to save a little bit of time here. I'm going to go ahead and put B squared equals, and I'm going to take 430.5 and square it, and then subtract from that 91.34 squared, and that will give me this number right here, 176,987. I'm going to take the square root of both sides, and I'm getting this right here, students. I'm getting 420.698 or 0.70. Okay, so the last missing side, which is side B, is 420.70. Okay, so there we go. We've solved another right triangle. Okay, let's take a look now at number 11. Numbers 11 and 13 tell you to find the altitude of the isosceles triangle and to round your answer to 2 decimal places. So this should be pretty simple, students. Here's your isosceles triangle right here. And let's see if we can't make it a little better somehow. Maybe. There we go. Alright, so this angle here is congruent to this angle here. And this is side B right here. Now, theta is 52 degrees, so I'm going to put 52 degrees here. And B is 4 inches, so I'm going to go ahead and cross this B off and put a 4 right here. 4 is the measurement of this entire bottom side here. And now they are asking us to find the measurement of the altitude or the height of this isosceles. Okay, so I'm going to drop this altitude straight down, and when I do that, I'm going to call this side over here 2 because you're cutting the 4 in half. So from here to here, we're going to have 2. This is a right angle, and I'm trying to solve for the altitude. Right here, we're going to call this X. So students, if you'll look, I'm going to highlight it in black. You really have a right triangle. I mean, here it is. Okay? So since you have a right triangle, you can use your trig function. So here's my angle, go straight across, x is my opposite side, and 2 is my adjacent side. So with that in mind, students, I can definitely use my trig ratios because I have opposite and adjacent. I'm going to use tangent, and so the tangent of 52 degrees equals opposite over adjacent. Multiply both sides by 2. 2 tangent of 52 degrees equals x. And so with my calculator, I'm going to type in 2 tangent of 52, and I will get out 2.559, so 2.56 would be the length or the height of the altitude right here. Okay? All right, very good. Moving on to number 13. This will be our last problem, number 13. And here we go. Let's see, number 13 tells us it'll be the exact same problem all over again, students. This angle here is congruent to this angle over here. The whole length going across would be 46. And we are asked to find the altitude. This would be a right angle from here, students, over to here would be 23. Half of 46, and this angle right here is 41 degrees. So students, once again, we have a right triangle, and here it is. I'm going to highlight it for you. There's your right triangle, okay? So with that in mind, here we go. I'm trying to solve for the length of the altitude. I'll call that x. So here's the angle I'm using, 41 degrees. So go straight across. This is your opposite side. 23 would be your adjacent side, so I'm dealing with opposite and adjacent, so I'm definitely dealing with tangent. So tangent of 41 degrees equals opposite over adjacent. Now I'm going to multiply both sides by 23, so 23 tangent of 41 degrees equals x. Okay, so 23 tangent 41 equals 19.993. Well, if you round that to 2 decimal places, you'll get 20.00 equals x. Okay, so there's the altitude or the height of the isosceles triangle right here, 20.00. Okay, students, I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.